Hello, Algebra 2 AB. Today we're going to talk about Chapter 12, Day 7, which is talking about law signs. Uh, now our focus is going to be away from right triangles. So everything that we've done so far within Chapter 12 has all been focusing on right triangles. Right triangles are very important to cover because obviously like many different objects we could just make out of right triangles. Well, let's say we have something that's not a right triangle. How do we solve that triangle if it's not right? That's what we're going to talk about today. So we're going to use the law of signs to find sides and angle measures within a triangle. All right, so let's move on to the first little slide here. This just outlines what law of signs is, and really it's just a proportion. Okay, it's just using proportions to set two ratios equal to one another. So if triangle ABC has sides of length A, B, and C, then the sine of A over side A equals the sine of B over side B, which equals the sine of C over side C. All right, remember the angles that we're talking about are capitalized, and then the side lengths are lowercase, so that we know where to plug in, lowercase a or uppercase a. Also, of course, we could write down the inverse. We could have A over sine of angle A, B over sine of angle B, C over sine of angle C. But we're not really going to use that. It doesn't really matter. There's no point in either memorizing, both of them or just, using one over the other. You use whichever one you want to use. If you want to use that one or if you want to use that one, doesn't really matter. I would just be consistent. So far, like I said before, we've been talking about right triangles. We can use law signs in any triangle, essentially. Um, so that includes right triangles. It works for right triangles as well. We just don't need to use it on right triangles. So what we're going to do is we're going to use law signs to solve a triangle if we're given angle side angle or angle angle side information. So essentially two angles and a side. And then also side angle information, two sides and a non-included angle measure. So let's just get to the chase and let's talk about some of these examples. So in this next one, we're going to find the value of x using these law signs. So I'm just going to write down law signs again right here. And then we're going to just plug some stuff in, see how it works, and see how we can find that side length. So here's our law signs. Sine of angle A over side A equals sine of angle B over side B, which equals sine of angle C over side C. We don't need these three ratios. All we need is two. And one thing that we absolutely need, we need to know information in one, like all the information in one of these three ratios in order to use law signs, or we need to be able to figure it out. So one of the things that I see right here is we have angle D and we have side D. And maybe I should have rewritten this a different way. I should have used D, E, and F since that's what our angles and sides are called. So I'm going to just rewrite this really quickly. Angle D over side D, angle E over side C, angle F over side F. All right, so we have angle D and side D. So we're definitely going to be using this ratio here. All right, so sine of angle D is sine of 105 over side D, which is 18. We're going to set this equal to a ratio in which we have one out of two of these things so that we can figure out that one unknown. We're looking for this side, which is side E, and we do have angle E. Okay, so we're going to set this ratio, sine of D over D, equal to sine of E over E. So now I'm just going to substitute angle E in. So we have sine of 105 degrees on 18 equals sine of 32 degrees on E. Now to solve this, we can just cross multiply and solve. Okay. So remember, cross multiplying, that's just something that we can do to get rid of the denominator and just like the result of our algebraic operations of getting rid of that denominator. So when we cross multiply, we have E times sine of 105, and that equals 18 times sine of 32. And now we've got to solve. We're solving for e, so we're going to divide by sine of 105 on both sides. All right, so e is just 18 times sine of 32 degrees divided by sine of 105. All right, if we type that into our calculator and solve, oops, where is, oh, duh, right in front of me here, we get about 9.9. All right, so using these proportions, we can find missing side lengths, and then we can also find missing angle measures. So I'm going to clear the board. We're going to go to the next one. And in this one, we're going to use law signs again to help us find that missing measure. Now this triangle is triangle ABC. So in this case, I can write down sine of angle A over side A, which equals sine of angle B over side B, so on and so forth. And now we're looking for side C, but notice something is we don't have angle C. That would give us two unknowns if we use this ratio. That can't happen. So either, we got to find something else in this diagram, and we can find angle C. We have two angles out of three in this triangle. So if we subtract those two from 180, we get 67 degrees. All right, so now we can use sine of C over C. So we have sine of 67 degrees over C, and we got to set that equal to a ratio that we know. Okay, and if we take a look, here's an angle and its side opposite, so we could use sine of angle B over side B. All right, we got to have an angle on its opposite side in order to use law of sines, or we got to be able to figure out an angle on its opposite side. All right, so we're solving for C here, so we're going to cross multiply. That gives us C times sine of 19 degrees equals 25 times sine of 67 degrees. Divide by sine of 19 on both sides. All right, so C equals 25 times sine of 67 degrees, all on sine of 19 degrees. All right, and once again, if we round that to the nearest tenth, we get 70.7. All right, awesome sauce. Moving on. I'm going to clear the board. All right, now in this case, we're going to find an angle. All right, so this is the first time that we're going to find an angle using this law of sines. So let's get started. Now I'm not going to write the whole law of sines anymore. Remember, we just got to use an angle on its opposite side. So that's angle K and side K. So sine of angle K, which is 125 degrees, on side K, which is 10, equals, well, we're looking for angle L, and we do have side L right here. So we can set that equal to sine of angle L on side L, which is 6. All right, once again, we're going to cross multiply and solve. I always say cross multiply and solve because cross multiply and divide might not be all that we have to do. So in this case, we have 10 times sine of L equals 6 times sine of 125. We're going to divide by 10. Okay, so we just cross multiplied and divided, but we're not done yet. All right, so we still have to get rid of that sine. And from our previous lesson about inverse trig ratios and solving right triangles, we know to get rid of sine, we just have to do inverse sine. Okay, so we're going to do inverse sine. Now I'm going to write this as one big fraction. Now, of course, we could just figure this out, and then do inverse sine of that, but I'm just going to write inverse sine of this whole thing here. All right, so if we do inverse sine of this whole thing, we get 29.4 degrees. Awesome, we got two more. Next one, we're going to find another angle measure. I'm going to clear the board again. All right, so once again, we've got an angle on its opposite side. In this case, we're going to find angle A, and we do have that opposite side. So we can set up sine of B over side B equals sine of angle A over side A, and then we can cross multiply. All right, so we have 23 times sine of A equals 5 times sine of 61 degrees. Divide by 23 to isolate the sine of A. So we have sine of A equals 5 times sine of 61 degrees, all on 23. And then we're going to take the inverse sine of this whole thing. So A equals the inverse sine, and now I'm just going to draw an arrow. There we go, of that whole thing. If we do inverse sine of that whole thing, we get about 11 degrees. All right, so the measure of angle A equals 11 degrees. All right, in the last example, we're going to use this and use what we've talked about previously in this chapter to solve the following triangle. Okay, so in this next example, we're going to solve this triangle, and although the last lesson did go over solving right triangles, there's only so much that we can use from that. We're going to sketch this triangle to start, and then after that, we're going to fill in some of these measures and then solve the triangle. Okay, like I discussed in the previous lesson, we could just write down what we're looking for. Side A, side B, side C, angle A, angle B, angle C. All right, at the end of the day, this is what we got to have. We got to have all 6 of those things. 3 sides, 3 angles. Now let's draw the triangle. It doesn't have to be drawn to scale. Okay, so you could just draw a basic triangle like that. You know, label it A, B, C, and then fill in the info. All right, angle A is 41 degrees. Angle C is 75 degrees. Side C is 28. Oops, I just wrote side C. I meant to write 28. There we go. All right, we can find that third angle because we got 2 out of 3. All right, so if we subtract those 2 from 180, we get 64 degrees. Let's fill in just some of the stuff that we know, so we know what we're looking for. So we got to find A and B. We got to find side B, side A, and clearly we can see that since this is a non-right triangle, we're going to have to use law of sines here. We've got an angle on its opposite side, so that means we can use law of sines. All right, so that's sine of 75 degrees on 28. We're going to set that equal to, you know, we just got to pick one. I'm going to pick A first. Sine of angle A, which is 41 degrees, on side A. Okay, in this case, once we cross multiply, divide that 75, we get A equals 19.0. And then if we set up the ratio for finding B, once again, we could still use this same first ratio. Once again, I always stress consistency. We already know that this angle on its opposite side, so we can set this ratio equal to sine of angle B, which is 64 degrees, on side B. All right, so 28 times sine of 64 degrees divided by sine of 75 degrees will give us B, and we get 26.1. All right, folks, that's Chapter 12, Day 7, Law of Sines. If you have any questions, please let me know. Send me an email. And thank you, and have a good day.